Our final topic is applications of exponential equations. Recall that exponential relations can be modeled by the general formula y equals a times b to the exponent x, where a is the initial value and b is called the growth or decay factor. So for example 1, the population of Ontario can be modeled by the equation p equals 9.4 times 1.0125 to the exponent t, where p is the population in millions and t the years after 1985. What is the predicted population in 2020? So first off, we have to figure out what is our t value. So our t value, remember, is 2020 minus 1985, which gives us 35. So to find our population, p, that's equal to 9.4 times 1.0125 to the exponent 35. So next thing is to type that into your calculator, and we end up with an estimated population of approximately 14.52 million. And just as a side note, you can see the population of Ontario as of April 1st, 2020 was approximately 14.7 million. In which year did Ontario's population exceed 10 million? In this case, we're given the population, so we're going to let p equal 10 million. So remember, population is in millions, so we're going to let p equal 10. And we need to solve this exponential equation. 10 equals 9.4 times 1.0125 to the exponent t. So for this example, we're trying to solve for the variable t. So there are two methods we can use here. We can guess and check a t value until we get our answer, or we can go to Desmos and solve for the point of intersection of y equals 10 and y equals 9.4 times 1.0125 to the exponent t. Or in Desmos, we're going to put in x. So let's go try that now. And then now we need to look for the point of intersection. So this might mean we need to move our graph. So there it is, just a small shift. And if we want, we can zoom out, see our exponential, but let's go back to here. Click on the point of intersection. Click on it twice. So you can see there's our y value of 10. And then 4.981 is the x value, or the number of years that we're looking for. So in this case, we've now found the point of intersection, and we had 4.981. So in which year did Ontario's population exceed 10 million people? We take our answer, 4.981, and add that to 1985. So the year we're looking for is equal to 1985, our starting year, plus 4.981, which means somewhere in the year 1989, or close to 1990, the population would exceed 10 million people. Example 2. The value V in dollars of a car t years after it's purchased is given by the following formula. Determine how long it would take for the car to be worth half its original value. So recall that for an exponential equation, that the 20,000 is our initial value. So if we want it to be worth half the initial value, we want our value to be half of 20,000. So we want our value to be 10,000. So same as above, we're going to let V equal 10,000, which equals 20,000 times 0.84t. We can go right to Desmos and solve, but since the numbers are so large, I'm going to show you a small trick you can use. I'm going to divide the 20,000 from both sides of this equation. And I end up getting that 0.5 is equal to 0.84 t. So same as before now, I'm going to try to solve the point of intersection of 0.5 with 0.84 to the x. And once we do that, we'll get our value for t, the time it takes for the car to be worth half its original value. So let's go to Desmos and try that. So type in y equals 0.5. Then I need to type in y equals 0.84x. So once I've typed in those two equations, I can easily click on the point of intersection, and notice since I used smaller numbers, I didn't have to zoom out to 10,000 or 20,000. So it's telling me that the time it would take for the car to be worth half its value would take approximately 3.976 years. So the time would be approximately 3.976. So approximately 4 years. And our last example. A 200 milligram sample of radioactive polonium-210 has a half-life of 138 days. This means that every 138 days, the amount of material left in the sample is half the original amount. So the mass of polonium-210 in grams that remains after t days can be modeled by the following formula. So first question is, why is the base 1/2? So you see here, we have a base of 1/2 for the exponent. Well, if you read the question, we're talking about half-life. So since we're talking about half-life, every 138 days, the sample is half its original amount. So why is the exponent t over 138? Well, it takes 138 days for it to reach one half-life. So in 138 days, if you had 100 grams of the sample, you would be down to 50 grams of that sample. So why is the multiplier 200? Remember, the number in front of the power is what we call the initial value. So that's how much you started with. So using this equation, let's answer a couple questions. So first of all, determine the mass that remains after 5 years. So remember, this is our t value. So our t value, which equals to 5, remember our formula is using days, so it'll be 5 times 365. That gives us 1,825 days. So therefore, the mass of our polonium is 200, that's what we started with, times 1/2 to the exponent of 1825 divided by 138. I would recommend you put that in brackets. So on your calculators, to do this calculation, you're going to do 200 times bracket 1 divided by 2, close the bracket, use your exponent button, and then again use a bracket and do 1825 divided by 138. So again, make sure you have your brackets in the correct locations. If I type that all in correctly, then I end up getting a mass of approximately 0.02 grams. So we've gone from 200 grams all the way down to 0.02 grams in 5 years. So let's try the next one. How long does it take for a 200 gram sample to decay to 110 grams? So this is our y value. Y equals 110. So for our formula, we have m equals 200 times 1/2 to the exponent t over 138. So that y value is going to go in for m. So that's 110 is equal to 200 times 1/2 to the exponent t over 138. So to make this a bit easier, I'm going to divide out the 200 from both sides. So I get 0.55 is equal to 1/2 t over 138. And that means when we use Desmos, I'm going to have y is equal to 0.55 for one of my equations, and y is equal to, if I like, 0.5 x over 138. So I'm going to make sure that's all one exponent. And then we can find the point of intersection of those two equations in order to determine the x value. So now let's go to Desmos. So y equals 0.55. So there are my two equations in Desmos. Notice we don't see a point of intersection, so we can zoom out by hitting the minus button, and then we may need to move to the side. So again, I'll need to click on the graph. It's still hard to see, but once I click on it, there's the point I'm looking for. If you want to make a better view, what you can do is you can change your y-axis. So notice I changed it from 0 to 1. So now I've zoomed in to see the graph a bit better. But again, if you look at my scale here, for my y-axis, since I was looking for a y value of 0.55, I thought, well, why not type in 0 for my low y value, 1 for my upper, and then it's easier to find my point of intersection. So we can see it's 119.02 days. Let's just say 119. So here are the homework questions that you should try. Important note, if you need help with questions 15 and 16, you'll need to see this example we just did. It's going to use this type of formula here. You're going to have to make some changes to the formula, however. And as another note, question 16 did not state the half-life, but the half-life of carbon-14 is 5,730 years.